Now let's do a t-test, and we're going to use our calculators to help us along with this. T-test is very similar to the standard hypothesis test using Z. However, now we don't know the population standard deviation, so we're going to be using T to get a more accurate estimate. Even though the calculation can be very messy when you're involving T, the calculator will handle all those details for us, so we just need to focus on the high-level concept of what exactly we're doing. In this scenario, we have a local union that claims their members are paid an average of $48,100 each year. So that claim is going to correspond to our null hypothesis in a moment. Based on your knowledge of the industry, you think the true average is higher. True average is higher. Okay, that will be relevant to us for our alternative. And you conduct a study to prove it. Your SRS of 32 people, okay, that's our sample size, 32 people, found an average of $51,500. Okay, that's your sample average, with a standard deviation of $8,700. Test whether your results are statistically significant or not. And remember, statistical significance means that your p-value that you get at the end of your calculations is less than the number that you picked ahead of time. So typically 0.05. If you have a p-value of less than 0.05, in this scenario, we're going to say that it is statistically significant. Otherwise, it is not. So again, we said our null hypothesis corresponds to the claim. We assume that the claim is true, so we say that mu, the population mean, is equal to 48,100. Now I took off the extra symbols so that we could just have the number ready to go to enter into our calculator. Now we have this little circle here, this 0 means mu naught. It's just another way of writing the null hypothesis because it's still technically a guess. It's not the actual population mean. That's why we put that little symbol in there. The alternative hypothesis is going to correspond to what we said here. The true average is higher. That's what we think. So given the choice of greater than, less than, or not equal, we're going to say it is greater than. Mu naught is greater than this number. Going forward, our x bar, our sample average, that's going to be this 51,500 number that we have here. That's the data that we collected. The standard deviation, Sx, 8,700. And then finally, our sample size is always called n, and n is equal to 32. So now we have all our values ready to go. And we take out our calculators, and we go to stat, the stat key, and we go to tests, which is where we found our confidence intervals. All our tests are also here. And we have all of these different types of tests to choose from. The one we're going to select is the second one down, t-test. So we select that, and since we don't have a list of data, we just have some statistics. We select stats as our input. For our null hypothesis, we type in 48,100, because mu is equal to that number. We jump down to our sample average x bar, and x bar is equal to 51,500, and you would type that in there. Standard deviation, Sx, is equal to 8,700, and we got that from the text above. And then finally, our sample size, n, is equal to 32, so we type that in the next line. Now, this next part is a little bit strange in how the symbols work, but as long as you write it down on your paper first, mu naught is greater than 48,100, this symbol is going to correspond to that. So you're going to select the one down here on the far end. If you make a mistake, you'll have a pretty good idea you made a mistake because you'll get a p-value of 0.9 something. If you ever get a p-value in the 0.9s, you know you just need to go back and select the other one, assuming that your data generally made sense. Your estimate was generally in the right area. It is possible to get very high p-values like that, but very unusual. Finally, we're going to calculate it and see what comes up. We do all this, and we get a p-value right here. P equals 0.017. Well, 0.017 is less than 0.05, so this scenario, we would say the data that you found is statistically significant. That means that you have proven at a 0.05 level that this claim is not true. The true population is not $48,100. There is, in fact, about a 1.7% chance that this number is actually true. So again, like everything in statistics, it is technically possible for this to be true, but very unlikely. Moving on to another example here, very similar example, but this time with some numbers. The local union claims their members are paid an average of $48,100, just like before. Based on your knowledge, you think that the true one is higher, so we're going to have same null and alternative hypotheses, and you conduct your study to prove it. Your SRS of the population produces the data below. Test whether your results are statistically significant or not. Instead of having all those stats, this time we have a bunch of numbers, a list of numbers. And we are going to put those into our stat list. So we go to stat, key again, we go to edit right away, go up and clear our lists, hit enter, and now we need to punch in all of these data values. So you punch them in one at a time. I'll pause the video, enter those in, you can do the same. Alright, we've got these all typed into our stat list. And once we have that, we're going to go to stat, we're going to go over to test again, go down to our T-test, and this time we're going to select data. Now, before we enter all these, let's just double check our null and alternative hypotheses again. Our null is that it's equal to 48,100. Our alternative is that it's greater than that. Now, if you just did the last example, you will still have those numbers hopefully in your calculator. So it should be 48,100 here. We have the greater than selected down below. And we're going to ignore the list and frequency. List should always be set to list 1, and your frequency should always be 1. So let's calculate that. And just like that, we get a p-value back. This time, from this data that we collected, it turns out these numbers are a little bit different than the last set of data. Our p-value is 0.2687. Well, that's significantly larger than 0.05, so this time our data is not statistically significant. With this set of numbers here, we cannot prove beyond any reasonable doubt that our null hypothesis is worth rejecting. So we failed to reject the null hypothesis. We do not have statistically significant results with this set of numbers here.